We are going to continue studying resonance patterns that we need to recognize in the molecules. So here we did before, one pattern was allylic lone pair. And we say by allylic that. We did that was a first pattern. And I'm going to write it here. So allylic lone pair, meaning in the next position relative to the double bond. We did another pattern, and that was this allylic carbocation. Oh, and the number 2 is already there, so I just need to say here, allylic carbocation. And then we say a third one, we say a lone pair adjacent to to say a positive charge. And here we said the example I gave you was this lone pair adjacent to positive charge, and we did this. Here's the things that we did before. Now, I'm going to do one more pattern, and that pattern is when we have, say, a pi bond, and it is between two atoms with different electronegativities. So, between, keep having wrong spelling, two atoms with, say, different electronegativities. I'm going to say different electronegativities. So I am abbreviating my writing, right? And that would be when we have, for example, this. Here's a double bond. So pi bond between these two. And we know that oxygen is more electronegative than carbon. So what we do here, that's another pattern that we recognize. We will move electrons over to the oxygen. And the resonance structure then will be, now oxygen has 3 lone pairs, negative formal charge, and here you will have a formal positive charge. So that was a third pattern. And the fourth pattern that I didn't mention is that was 3, 4, that's a 5. This is when you have a pi conjugated system on a ring. And this is what we have here. I want to make it all fit in one screen. So here you will do an arrow. Remember the arrow show flow of electrons. So if I move those electrons over here, then I need to necessarily move the other electrons because we don't want to expand the octet. So the final structure that we get, moving all of those, the resonance structure here, you will have double bond here, and here. So that is my fifth pattern. So always remember, you're going to show with the arrow flow of electrons. You do not break. More spelling things. Do not break single bonds. And remember, octet rule. That's what we need to remember. Here are the patterns. And in another video, what we're going to do is apply all of that and recognize those patterns and draw resonance structures. Bye for now.